In this video, we're going to go over some basic rules from a field of mathematics called combinatorics. Now, combinatorics is a very deep field. You can take multiple classes just on that, but we're just going to go over 3 quick rules that we can use from that field that are going to help us in this class. The idea behind combinatorics is how can we count how many ways something can happen without actually having to write all of them down. And this is going to be very important. For example, let's say you're having a deck of cards and you're going to give someone 2 cards, you're playing blackjack. If you want to figure that out, it's going to be quite a lot of possibilities, and writing it all out would take way too long. But we can use these rules here to get answers very quickly using these formulas. Also, your calculator are going to have buttons to help you with these, but if you don't know what these are and how to use them, then having those buttons aren't going to help you at all. So the first one is the multiplication rule of counting. So if you can do the first thing m ways and the second thing n ways, there are m times n ways to do both. Now let's talk about outfits here. Let's say you own 6 different shirts and 3 pairs of pants. And I want to say, how many different outfits can you make with this? Well, you can choose 6 different shirts for your shirt option. You can choose 3 different pants for your pants option. By the multiplication, we multiply them, and that would be 18 different outfits. Now, this works whether you're doing 2 things or if you're doing more than that. Let's say you also own 2 pairs of shoes. And if you want to find out how many total outfits they're going to be when you include shoes as well, you just multiply that 2 in there with everything else, and now there's going to be 36 different outfits without ever having to write down all the different combinations. The second rule from combinatorics we're going to learn is called permutations, and this is going to be if you want to take k objects out of a group of n objects, and the order you take them matters, use permutations. And in particular, you're going to see this capital P here indicating permutations. And then you're going to see these 2 little numbers, one on either side, P and K. That is going to be how many ways you can take K objects out of a group of N objects, and the order, in fact, matters. Now, the formula for this, which you will see, say, in a combinatorics book or our textbook, is this really weird notation here, which has this exclamation point, which means factorial. Now, you may have never seen that before, so I'll go ahead and tell you what that is. So when you have a number and then an exclamation point, it means you start with that number and you keep going down by 1 and you keep multiplying until you get to 1, and then you stop. And whatever answer you get, sorry, it's not 60, it's 24 here. 4 times 3 is 12, times 2 is 24, times 1 is still 24. That's what factorial means. You just keep multiplying down, down, and down. And so you see we have these 2 different factorials involved in this permutation formula. Again, as I've said so many times before, don't try to memorize this formula. Your calculator has a P button on there, and you're just going to tell you what the N is and the K is. Now, let's do this for example here. Let's suppose we have 30 people in a competition and we want to give a first, second, and third place prize for whatever competition it may be. And I want to say how many different ways could we give out those prizes? Well, we are going to pick 3 people from a group of 30, and the order matters because getting first place is different than getting second place. And if I put this in my calculator here, and there will be a video separately showing you how to use your calculator to do this, we will have 24,360 ways. So if you have a group of 30 people and you want to see how many ways you can get first, second, and third place prizes out, it's over 24,000 different possibilities. Okay, well, let's suppose we're picking people from a group, but we don't care about the order. It doesn't matter which order we get them in. So if you want to take K objects out of a group of N objects, and the order you take them does not matter. So it doesn't, you're not trying to get first, second, and third. You're just taking 3 people that are all going to get the same prize. We use combinations for that. And so for these, instead of having a P there, it's going to be a capital C. I'll give you the formula again, but again, we're almost never going to use the formula itself. It's very similar to the permutation formula, but there's this extra factorial on the bottom. And if I wanted to take now 3 people from that group of 30, but I no longer care about, first, second, and third, I want to give them all the exact same prize here, so they're all equal to each other, then what the answer would get here is 4,060. So there would be 4,060 ways to pick 3 people from a group of 30 where I don't care which order I pick them in. Now, if I were to go back to talking about, say, playing blackjack, there are 52 cards in a deck, and if you want to take take 2 of them out of that to get your 2-card hand in blackjack, what you'd end up getting is 1,326 different blackjack hands. Okay, so we can do calculate if you wanted to talk about how many different 5-card poker hands there would be. It'd be C52 5, and if we put that in our calculator, then what we're going to get here is a very large number, 2,598,960 different possible poker hands. And again, I do it that way because it doesn't matter which order you get the cards in, it's the same poker hand. Now, of course, you could play other games where the order matters, in which case you would use permutations rather than combinations. So these are our 3 quick rules here, and using these will allow you to find all sorts of probabilities. If you think back to the beginning of the probability, the first video, we said if you're trying to calculate probability, you take the number of outcomes in your event divided by the number of outcomes in the sample space. Well, now instead of actually writing those things out, you can just use permutations, combinations to calculate how many things are in your event, how many things are in your sample space, divide them, and you get your probability. So these formulas are going to be very, very useful. We're going to show you how to do it in your calculator, and you will use these quite often at this point in time.